Hello everybody. I just thought I will start a little series about quantum machine learning. I just started to learn quantum computing a couple of days ago, but it's so amazing that I thought I will share it with you. And I've just started to create a little notebook for you. And this notebook here is basically running in a Lyra AI in Jupyter Lab. So you have here a little table of contents. So it's everything interactive, and I will gradually um, add content to it. But actually, I'm stopping here with quantum neural networks, so it's already worth to use the notebook. But of course, I will improve it. So let's actually see what environment I'm using. Here I'm using Jupyter Lab with the Elira AI plugin, and I've created a Docker image for you to use it. So I've installed all the necessary libraries. So we are using a library here called Qiskit. This is the IBM open source environment for quantum computing. So you can run actual quantum computing code against our quantum computers in the cloud for free. And in addition, it has simulators and a lot of other interesting stuff. Um, so this notebook here is based on the Qiskit textbook, so I can really recommend this Qiskit textbook. It's for free as well, but of course it just takes more than just 15 minutes to get through it. It's very advanced, but it gives you a good start and overview as well. So anyway, let's start with quantum machine learning, and for that we'll just start with a little recap on quantum physics, and we only need two concepts initially. So one is superposition. So superposition means that any two or more quantum states can be superimposed, resulting in another valid quantum state. So in other words, if you use a photon as an example, a photon can be, for example, in the spin up and spin down state at the same time. And then only once you measure it, it collapses into one of the state. This is called the cat state. If you want to hear more about that, just check out the Schrödinger's cat. I think most of you know the Schrödinger's cat example, so I won't go into details here. The second interesting and important concept is entanglement. So this means that properties, physical properties like position, momentum, spin, and polarization between two or more quantum particles are correlated. So, for example, if the spin of one photon is measured to be up and the other photon is entangled with that, it is guaranteed that the other photon has the spin down state. And I was always wondering how to create such entangled photons, and it's relatively simple. There's a special type of crystal called nonlinear crystal, and if you shoot photons through it, occasionally it happens that higher energy state photon, so this means at a shorter wavelength, decays into two longer wavelength, lower energy state photons, and that two photons are entangled. So this is called spontaneous parametric down conversion. And as I said, it's a special type of nonlinear linear crystal which can be used to produce entangled photons. Okay, so those are the two concepts you need to know about quantum physics. And the next thing we will cover here is quantum computing hardware, and especially the transmon, which is used in our quantum computing chip.